Hello everyone, you are welcome to today's class. In this class, we are going to make it a form of series to explain the solution in a textbook called All-Inclusive Calculation in Physics by Solomon Dauda Yako. It's a very interesting textbook, so please stay tuned as I will be updating you on the subsequent topics, starting from speed, velocity, and acceleration. Speed is defined as the rate of change of distance with time, and it is given to be distance all over time. Distance over time, and the symbol, some textbook use D. Some textbook use D to represent distance, that is to be D all over time. D over time instead of S. So it is interchangeably used, either S for distance or D for distance all over time. So that is average speed is equal to total distance all over total time. Are we clear? And the SI unit of speed is meter per second, or you write it as meter per second like this. I hope this is taken. So from this formula we have, let's quickly solve this example. A student walks a distance of 3 kilometers in 20 minutes. Calculate his average speed. Solution. Average speed is equal to total distance all over total time taken. So I said we can use D or S, D all over T. So from this question, distance of 3 kilometers. So D is equal to 3 kilometers. Except otherwise stated that you should walk in the unit kilometer, always convert every unit to meter. Either if it is centimeter, convert it to meter, except otherwise stated that you should work on it. Or if it is objective, you go through your options and see that the answers are in kilometer, then you can leave it. Otherwise, always convert to meter. Is that clear? So to convert this one to meter, remember we have 1 kilometer. 1 kilometer is equal to 1,000 meter. So kilometer is the bigger unit, meter is the smaller unit. When you are converting from a kilometer to meter, you multiply by standard of conversion rate, which is 1,000. But when you are converting from meter to kilometer, you divide by rate of conversion, which is 1,000. I hope this is taken. So if I am converting now that I have 3 kilometers, so multiply by the rate of conversion, which is 1,000. So it will be 3 multiplied by 1,000, which give me 3,000 meter. Is this taken? Then the next, here you are giving 20 minutes. This is unit of time. So since it is in minute, just like what we have here, always convert to second, which is the SI unit of time, except otherwise stated that you should leave your answer in a minute, or the options in the objective the answers are in minutes, right? So since we are talking about average speed now, the unit is meter per second, except the option there you have in the objective are kilometer per hour, as the case may be. Always convert to meter, this one to second, so that you end up having meter per second as the unit of speed. I hope it is taken. So since the time is in minute, so T, which is equal to 20 minutes, is equal to what is the conversion rate from minute to second? We have 60 seconds is equal to 1 minute. That is 1 minute, right, is equal to 60 seconds. Just like what we have here, minute is bigger than second. So if I'm going to the smaller one to second, I'll multiply by 60. If I'm going to the bigger one, the minute, I will divide by what? 60. So now I'm converting from bigger one minute to second, which is the smaller one, I will multiply by 60. So therefore, I have 20 multiplied by 60. That is in seconds, right? So that will give me what? 1,200 seconds. So that is time. So I've gotten my time. The next thing is to what? Input that in my formula. Average speed is equal to distance all over time. So this will be equal to, what is the distance? 3,000 all over time, 1,200. So this 20, we cancel 20 here. I'll be left with what? 330 all over 12, right? Then what is 30 divided by 12? That will be 2.5 meter per second. 2.5 meter per second. The second question says, a driver traveling at a speed of 115 km per hour received a text message on his mobile phone. How far is he in kilometer? Look at this question now. Say, how far in kilometer? So in kilometer, 20 seconds later from when he received the text. So now the question says how far in kilometer, shows that this should be left like this. So since this is going to be like this in kilometer per hour, I have to convert my time to hour as well, from second to hour. So these are the things you need to consider. Since you have to answer your question or leave your answer in kilometer, then you will not touch this one given to you in kilometer per hour. You will not convert it to meter per second. Please take note. You will not convert this one to meter per second. Rather, we're going to convert second to hour so that you have the unit to be the same. Is that taken now? So let's do this. Solution. Here, you are given the speed. Speed is equal to 115 kilometer per hour. And here they say how far. This how far here is asking of what? Distance. How far? Distance. So we're looking for distance. Distance. I say we can use D or S. Distance is what we are looking for. I'll put question mark. And the time taking T is equal to 20 seconds. I said, since the question says you should leave your answer in kilometer, you are going to convert second to hour because your speed is in kilometer per hour. You cannot have kilometer per second. Is that clear? So now how do I convert to from hour to what? To second. So the standard is that 1 hour is equivalent to 3,600 seconds. Is that clear? Hour is the bigger unit, second is smaller unit. When you are converting from bigger unit to smaller unit, you multiply by the rate of conversion. Here is 3,600. When you are converting from second to hour, you divide by what? 3,600. This implies I'm going to have 20 divided by 3,600 in hour. Sorry, is that clear? So this is the conversion, 20 divided by 3,600 in hours. So when I'm done with this, then I'll make use of my formula. What is the formula? The speed or average speed is equal to distance all over time. Okay, I might decide to make this subject of the formula, the distance subject of the formula here. To make distance subject of the formula, I can just make this one about 1, then I cross multiply this one to multiply this. So D multiplied by D, I'll have D is equal to speed multiplied by time, the speed multiplied by time T. So distance that I'm looking for is now equal to, what is speed? 115 kilometer per hour, simply in kilometer all over hour. So let's do it like this. Multiply by 20 all over 3,600 all in hour. So 1 hour is in numerator. We cancel the hour in denominator. You see your answer is now left in what? Kilometer. So in that case, D will be equal to, since this one is numerator, this one is also numerator, I can have 115 multiplied by 20 all over 3,600. So what is 115 multiplied by 20? That will give us 2,300 all over 3,600. You can use your calculator direct. D will be equal to 2,300 divided by 3,600, 0.638 kilometer. 0.638 kilometer. That is the distance. Then the next is velocity. Velocity is defined as the rate of change of distance with time in a specified direction. The rate of change of distance with time in a specified direction. It can also be defined as the rate of change of displacement with time. What is displacement? Displacement is a distance traveled in a specified direction. It's a distance traveled in a specified direction. So by formula, velocity is equal to displacement all over time, or change in displacement over change in time. The same symbol, we use S or D to represent either displacement or distance, then all over time. It has the same unit, which is a meter per second. In the exam, you might be asked, what is the differences between speed and velocity? Speed is a scalar quantity, while velocity is a vector quantity. This is the main differences. Speed is a scalar quantity. It has magnitude. It does not have what? Direction. It does not have direction, right? While velocity has both magnitude and direction. So it's a vector quantity. The same differences between speed and velocity is the same with distance and displacement. Is that clear now? So, but the similarity is that they have the same unit, meter per second. And with respect to distance and displacement, they have the same unit, which is what? Meter, centimeter, kilometer, as the case may be. I hope this is taken. Now, rectilinear acceleration. The term rectilinear acceleration means the rate of increase of velocity along a straight line path in a unit time. So if the velocity of an object changes, it can either be acceleration or deceleration. Acceleration is the rate of increase in velocity with respect to time, while deceleration is the rate of decrease of velocity with respect to time. Deceleration is otherwise known as a retardation. So when the velocity decreases, it is termed as a retardation or deceleration, and when the velocity increases with time or increases with time, it is termed as a acceleration. I hope this is understood. So from what we have done, we use the formulas for distance, right? So I want you to try this and solve to see if you actually understood what we have discussed so far. Number 1 says a boy cycles continuously through a distance of 1.0 kilometer in 5 minutes. Calculate his average speed. This is similar to question number 1 we just solved. So look at it critically. If something you don't understand, go back and take your time, watch the video. I trust you are going to be able to solve it. Try it and solve it, please. The second question, and let's put 1. The second question says an Air Force jet flying with a speed of 335 meters per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? And the answer there is 1,675 meters. So I will leave it for you. Ask yourself, do I need any conversion in second question? I doubt. You don't need any conversion. This one is in meter per second, this one is in second. Then you work it, use your formula and work it direct. I think the only place you need conversion is question 1. Convert kilometer to meter, convert meter 5 minutes to seconds. Then you you put down your formula, you input and get your answer. I hope this is understood. Watch out. The next topic is going to be equation of motion and how to use it to solve problems. Thank you for listening. We'll meet in the next class.